Hello, everybody. Happy to meet you all in day two of our cloud computing session. So, in our previous lecture, we went into the history of cloud computing. So, we started from the 60s era, which introduced the client server computing, later on to the peer-to-peer computing in the 70s and 90s. And after 90s distributed computing, and from then on we went to clustered computing, and then from there we went to the cloud computing paradigm on big scale. So along with this, we had discussed about some key features that represents each of these computing techniques. And in continuation to that, in today's session, we're gonna be discussing in detail about an important technique which gave the pavement to all these computing paradigms that we have. Let us first understand what computing is. So on basic level, from common man's perspective, we can tell this as some calculations performed. So when it is done with some technological paradigms or architecture or a structure, we give the name to that specific computing as either grid computing or cloud computing or quantum computing or green computing. So it depends on the domain it works on. So I can call computing as collection of computers, which are your devices basically with your technology performing some calculations, just processing of your data, and importantly executes your programs. So this is a basic definition of what computing is. So, so you can divide this into two portions as the basic arithmetic operations, two complex operations, which we call it as the AI machine learning operations and simulations. So it scales from operations, so arithmetic, basic arithmetic operations and logical operations to simulations, artificial intelligence, and machine learning. So to tell in brief, so to enable all these operations to happen in a network or within a group of computers, computing serves as the backbone. So of course it has various functionalities attached to it, or it comes along with it. So the first important functionality that computing in any domain possesses would be data processing. So what is data processing? So obviously there's going to be some set of operations, some set of codes that's going to get executed in these group of computers. So user is going to request for some resources. He's going to perform some computing task. It might be an end user or an enterprise or an organization. So the data centers is going to be viewing everything as a common request. And they're going to be serving the end users based on the request, or the organizations based on the request as they demand. So data processing usually involves storing, retrieving, manipulating your data, and most importantly, all these operations has to be performed efficiently. So, what does efficiency mean here? It plays an important role in any of the computing scenario because based on this parameter or based on this factor, the cloud service providers or any of the computing service providers marketplace is fixed. So, how do you decide it? So, efficiency means using the resources as effective as possible, providing the resources to the users as effective as possible by reducing computing wastage. So all the computing resources that's gonna get operated or functioned in your computing environment is gonna be using your compute, storage, and processor, basically, right? So we had seen it in the previous session. So this not an effective computing framework is something which enables data to be efficiently used without any resource wastage. So reducing computing wastage. Second important functionality which plays a major role are the set of algorithms and logical operations. See, algorithm is nothing but a set of predefined steps. So every time there is a request raised in a computing environment, how are the requests taken? The manner, the pattern in which the requests are taken, how are the resources allocated, the pattern in which the resources are allocated. So all these are usually done with help of algorithms. These there are some set of algorithms, and there are n number of algorithms available which performs these logical operations. So I can call this as procedures to solve a given problem. Another important functionality that comes in role is your hardware and software. So hardware are your physical components. So when I talk about the physical components, what would be coming in your mind? Obviously, your processor, RAM, and hard disk drive. So which we call as compute. So RAM is your storage, so HDD is your storage, and this is your capacity. So these are viewed as your computing capacities. So along with it, your networks even comes into the role. So that's again your network requirement falls under your a hardware requirement for accessing any data or to work with any data over the cloud or any computing paradigm. Okay. So when I talk about the software, it's a set of codes or lines of programs. So So that's again written in a specific language which is understandable by the humans, but further it gets translated to binary so the computers can understand only zeros and ones. So to make the communication possible between the computers and human interaction, we have various languages which starts right from C, C++, we have Java, Python, PHP, HTML, um, we have Perl, not limited to. So another important functionality that comes into the list is your networking, which I had just mentioned in the hardware resources. Of course, all these clients, servers, the peer nodes, or whatever the node we call a cloud. In terms of cloud computing, we call a cloud node or a server, a data center, an instance. Whatever is created in your cloud environment is all connected through the network. So we have to have an established network to send and receive data. So that's about computing. So sorry, I forgot to add one more point, uh, which gives way to the latest advancement, which is the artificial intelligence and machine learning. So we can describe artificial intelligence as something which mimics a human knowledge. So the machine understands how the human works, how the human responses. So based on those, the machine tries to mimics the data. It tries to serve the user with it. So it's again viewed as an automation provisioning system technique. And machine learning is again gained greater attention in recent days because this is somewhat similar to artificial intelligence in analyzing the user's data, where there are some important decision making algorithms based on your data, sentimental analysis, and all those type of semantic web features which are incorporated in your machine learning algorithm, which are classified as supervised algorithms, unsupervised algorithms, semi-supervised algorithm, to capture humans' responses, how they act with the computing resources, and based on that the users are served. So machine learning is again decision making algorithms with uh, supervised learning algorithms, unsupervised learning. So that's about the characteristics or the functionalities of how any cloud computing domain is going to work. So we have various types of computing domains or patterns available, not just limited to cloud. The first and the common of all is going to be obviously your cloud computing paradigm. The second I'm just going to give an overview of what are these computing paradigms, how it features in our current scenario or society. So, and it's there are a lot of research going on all these computing paradigms, and it's obviously going to get integrated with AI, ML, and it's going to help the end users and people around the globe to make lives simple. Grid computing and edge computing. Okay. So we all know cloud computing is again on-demand service provided through the internet. So when I talk about on-demand service, again, we'll have to remember it's always the three main important computing services which are provided, which is the processor, storage, or memory. So these services are provided over the internet based on our pay-as-you-go model. So we pay only for what we use. Say I'm gonna be using an instance in AWS, which is a service provider in cloud. I am just going to be paying only for what I'm gonna be using. Say I have two instances, and this instances is planned to get executed on weekends. I'm planning to execute these instances on weekends because I'm working on a project and developing a project, and I want continuous integration of the instances. So 24 by 7, I want the instance to be run. So I pay only for the weekends. I don't pay for the weekdays. So I'll be working on the instance on my local computer on weekdays. So only when I deploy it on the cloud, I would be running the instances. So I just pay for what I use. So that's cloud computing. And quantum computing is again an important and interesting topic which works with photons, neutrons, and electrons on quantum mechanics and physics, which talks about photons, superposition of electrons, neutrons, and protons. And grid computing, as we had seen in the previous session, it is again distributed computing scenario. And edge computing is again gained so much of attention in today's society because it makes a given number of processing is done closer to the closer to the user's zone or location. So in cloud computing, we're gonna be diving deep into data centers and availability zones. So when we discuss about that, we would be having a brief idea about what are zones and how edge computing works in processing the request or the data somewhere closer to the user's point. So it again includes IoT devices where a Raspberry Pi operating system is involved, and this can take the burden off from the data centers by processing the request inside the IoT Raspberry Pi device. So that's edge computing. So in recent days, it's been used in sensors, cameras, CCTV cameras, and smart agriculture and traffic system processing and all those type of areas. Edge computing has gained particular attention. So from there, let's just quickly pop into cloud computing in detail. So as we had already discussed, cloud computing allows me to access the storage, CPU, processor, servers, databases, networks, and software with just internet connection. All I need to have is some good speed of internet and I can access all these resources over the internet. Say at any given point of time, I would like to access my data which has been uploaded from my local computer to the cloud. And say there's some downtime with my hardware. I can just immediately borrow a laptop from a friend of mine or a relative of mine, and I can just access my data from the cloud with just internet access. So, cloud computing is not binded, or it's not attached to your local computer. There's a remote computer, a remote data center, which is going to be hosting all your data, and these data centers are further divided into zones, and your data is replicated over there. It is beautifully balanced over there, and load balancing is appropriately maintained. So it's basically virtualized in the background to give you a view that you're accessing your data from your local computer, but literally you're not doing it. You're accessing it from a remote server, but it gives you a view as though you're doing it in your local computer. That's cloud computing. So the basic of resources that you're going to be accessing is confined to storage, processor, network, databases, servers, and software. So So there are three tech giants which provides these services to the end users or the enterprises or operation organizations. The first one is Amazon, AWS, Microsoft Azure, and the third one is Google Cloud. So you can call them as cloud service providers. Okay, so the cloud services comes in various flavors. So we're gonna discuss about the services now. So say for an example, let's talk about a real-time scenario where I have my local machine, and my local machine has 1 TB of HDD, 4 GB of RAM, and i7 Intel Core processor, and NVIDIA GeForce. See, these are my configurations. So, say I'm working on an application and I would want an advanced database to be installed in my system, which is not possible because of the hardware configuration that I have right now. So, I would want to scale up my configuration in my laptop, which is gonna be a heavy capital investment for me to just invest for an application to work on. So, all I can do is just quickly log into any of these services given by these tech providers, cloud service providers, and I can create an account there. I can open the console. I can immediately buy my resources based on the pricing and meter based techniques that's provided by each of these services. Again, each of these service providers is going to be using a different policy for billing and pricing. So, having said that, so there are various flavors of services which are provided as something called infrastructure as a service. So here I have my system with me, but I would want to increase my storage, and I would want to virtualize my network. I would want to create instances virtually. So there is a platform, the infrastructure, which is basically provided for me. So they provide the physical infrastructure literally through the virtualization technique to create the instances and do my developing operations or whatever the operations that I would like to make on cloud. So this helps us to create VMs, storage, networking. So the basic architecture for working on any application is gonna be provided. But you have to remember the OS is not provided. But if you want, you can have it. But the developing environment is not provided. Sorry, the developing environment is not provided. So we have to have the softwares related to that or related to the application that we are working in order to execute our code. So some examples of your IaaS platform includes your AWS, Azure, VM. So the second service that is provided is platform as a service. Okay. So along with all the infrastructure, which is going to be having your VMs, your storage, your network and all those, there's going to be an add-on to this, which is your development environment is given to the user. So you don't have to worry about what database you're going to be using for storing your data. Say Facebook is using Cassandra. So it can just have a service initiated for it. Facebook can just uh, go on the renting basis, so they can use the services provided by AWS or Azure and just import the image or the container of the Cassandra DB. So there are various databases available on your platform as a service option, which enables you to take as a service, use it, and terminate the service when your job is done. So development envir- environment for the developers helps to develop the application. So your infrastructure as a service basically has only your VM, storage, networking features enabled. You have to worry about your development environment. But here in your platform as a service, you don't have to worry about your VM, storage, networking, as well as your development environment. All you have to do is be ready with your coding skills and start with the development. We have one more service which is totally effortless from the user's end. Software as a service. So, which means you don't have to worry about the VMs, the storage, your networking, your development environment, even the software. You don't even have to create a software literally to work on your task, your everyday events, or your schedules, or any of your tasks. So, it is a fully developed software. So, I can point some examples, which is your MS Office 365, Salesforce, and Google Workspace. So other examples include your Gmail. So every day we log into our Gmail accounts, we check our inboxes, we check our outboxes, we send emails, we receive emails. We aren't literally doing anything from our end to do those activities, right? To perform those functionalities. It comes as a total package to us at our footstep without any effort from our end. All we have to do is pay for what we use. So that's about the services. So basically, all these services works with an important techniques or has an important technique as the backbone of these services, which we call as. So not just for these services, virtualization is the backbone of cloud computing. So this is again a detailed topic. There's going to be some interesting terminologies and some techniques that we're going to be discussing in virtualization, the types of virtualization in depth, and let's discuss it in the next session. Thank you. Have a good day. Bye bye.